All right, let's go ahead and do this. These are note 6 about graphing polynomial functions. So we've seen a lot about zeros, about graphs, and we've looked at things on our graphing calculator before. Today we're going to look at how to actually sketch these and also how to find the zeros on your graphing calculator. So scroll down. I'm not going to do this entire table with you. I would recommend that you fill in at least 2 of these boxes to take a look and really get this pattern down. And the key is up to help you make sure you're understanding what's going on. The biggest thing that you need to be able to identify about these functions is, okay, you're going to take your graphing calculator, plug in each function, and then try and analyze what is really happening. Now, these first 2 things, you do not need a graphing calculator for. You just need to look. Even or odd degree just means, okay, look at the biggest exponent you see. In the first one, it's x squared. Is 2 even or odd? You guys know that would be even. That's going to tell us something about the end behavior of our graph, whether it's a parabola, something else, x cubed, something bigger. It's going to tell us what that's going to look like. And positive or negative means, okay, whatever the biggest term is, right? So in this case, again, it's x squared. That value is positive. And if you look at something like down here in number 3, that value is negative, right? So there's different types of graphs that we see. Now, the rise and fall that they tell you to try and figure out in these last 2 boxes, that's kind of confusing terminology. When I was reading this, you want to think of rise as like pointing up, arrows pointing up. Fall is arrows pointing down. So however you want to describe that is fine. In this note sheet, it's going to say rise or fall, but as long as you know what that means, you should be able to fill in this table. So moving down with that, I want to continue on to the rest of this. So I'm going to tell you the pattern that you need to realize with this. So what you're going to see as you fill in this table is that when the degree is even, your arrows are going to be pointing the same direction. So either they're going to be going up. Maybe I'll draw these in here. You don't need to draw these with me. They're either going to be both pointing up, both pointing down. They're never going to be facing opposite directions, right? And the positive leading coefficient tells you they're facing up. Negative tells me they're both facing down. Now that looks a little different with odd degrees, where they're going to be facing different directions, kind of like that graph of x cubed. Okay, so I'm going to fill in the box on the bottom, but I just want to try to explain before that this is kind of what those graphs are going to look like with an odd degree. Okay, so let's go and fill in those exact graphs that I just did in the actual right spot. So what inferences can we make? A positive leading coefficient means if it's an even degree, both facing in the same direction. And if it's negative, both facing opposite directions. This is not always exactly what the graph's going to look like. It could look something like this, where there's a lot of turning points, which is what we're going to learn about in a bit. Or it could look just like a normal parabola. Just kind of depends. An odd degree is always going to start down and move up. So we're moving from fall to rise. And this is going to be a positive graph. And the negative graph for an odd degree is going to look like the opposite. So starting from the top and then going down. It's kind of like when we learned about translations and reflections. If we were to flip it over the x-axis, that's what a negative leading coefficient does to our graph. So now you just got to figure out what we can do with that information. In 7 and 8, they ask you to determine the sign of the leading coefficient and whether it's even or odd. My first thought is, okay, in 7, they are both facing the same direction, right? Because they're facing the same direction, this must be an even function. Again, I don't know what it is. It could be x squared, x cubed, or not x cubed, x to the 4th, x to the 6th, something like that. And whether or not it's positive or negative, well, they're both facing down, so negative. That's my 2 answers for that one. And then the last one, they are facing opposite directions, so leading coefficient's going to be odd, really the power, and then it's going to be positive because it doesn't look exactly like the graph we drew, but it goes from down to up. Down on the left, up to the right. So we get a positive leading coefficient. All right, now we are going to talk about maximum, minimum values, a couple different things about these polynomial functions. First things first, there is something that we are going to call turning points in a polynomial, which is where the graph changes directions. So if you look and zoom in at this specific graph, you look at that point right there at the top. First of all, we're going to think about that, I'll tell you right now, as some sort of maximum point because it's higher than the rest of these points here. We'll talk about that definition in a second. But really what this is a graph where we turn from, okay, I'm increasing, increasing, and increasing, and then at this very point, I start decreasing. My graph starts going down. That is what a turning point is called. So it's when the graph switches direction. Now, what I just tried to explain was that maximum point. If the turning point's higher than any nearby point, right, so it's the biggest point on this little curve, that's going to be called a relative maximum. And it's a relative maximum because it's relative to the graph, right? There are points bigger than this point right here, way up to infinity. But it's a relative maximum at that point that we're looking at on the graph. And now if the point is lower, it's a relative minimum. So you're filling those in. You need to know these vocab words just to kind of describe these things. And then finally, we've got any maximum and minimum values that we see here, the relative maximum and minimum, are called extrema. That's just, again, a vocab word that we use. Now you got to go back in your head and try to recall these increasing and decreasing, this idea of what's happening on a graph. So remember, if as my x gets bigger, my y is getting bigger, it's increasing. And if as x gets bigger, y gets smaller, so it's going down, that's going to be decreasing, okay? One of the biggest things that we're going to learn about turning points is that a polynomial can have only n minus 1 turning points. Now, what is n? N is the degree of your function. So x to the n is going to be the biggest degree. Let's just say I had x to the 5th plus, x to the 4th minus 3x cubed, right? And all this other stuff. The most turning points that this graph can have is 4 because it's 1 less than the highest degree, and the highest degree is 5. So as you practice, you'll start to figure that out and learn that, and MathXL might ask you about that as well. All right, so for this section, we are going to talk about filling out one of these graphs here, figuring out the relative and absolute max and mins. Okay, so we are going to look at the turning points, and those are going to define those for us. Now, relative minimum and maximums are just kind of locally in that area, right? So my relative minimum in here is going to be a lower point where all the points are higher than it, like a little upwards U shape, which looks to be at 3, 0. That looks to be a minimum point here. But what they mean by absolute is the absolute minimum point on the graph. Is it the lowest point that exists at all on that graph? So there can either be a point, or you can say none. There's no absolute minimum. So like in this case, this minimum point, 3, 0, are there any points on that graph that are lower? Well, it looks like that graph is going to go to negative infinity. So I would have to say no. There are no points that are going to establish an absolute minimum, because really my absolute minimum is negative infinity. It's not an established value. For relative maximum, it looks like this point up here is a maximum point, right? It's like a parabola facing downwards, a turning point where all the points are lower than it. So in this case, this point looks like it is 1, 4. But it looks like, again, my graph goes all the way up to infinity, so there is no absolute maximum for this graph. Now, the number of turning points is just how many points we see the graph turn, which happens to be 2 in this case. But take, for example, this other point, or this other graph, where I've now got more than one maximum point. Now, it looks like these points are something along the lines of negative 2, 6 and 2, 0. Now, those 2 points, we have to think, those appear to be relative maximums to me, right? So maybe I might label those on my sheet. But then when they ask me for my absolute maximum, look at both of those maximums and think, okay, are there points that are larger than either of those? Well, this one, it looks like there's all these points above it, so that's not going to be our absolute maximum. But negative 2, 6 appears to be the biggest point on this graph. My graph does not ever reach positive infinity, so that's my absolute maximum point that exists on that graph. Okay, so continue to fill out the rest of these on your own, and then we'll move along. Now, I'm just going to show you very quickly with an example up here. I actually have the same exact example in my calculator. And we're going to do the same thing we've been doing. I'm going to click graph, and I can see my graph there, so maybe I should, make a little sketch of it. I got something that looks, let's see, kind of like that. Now, how do I find the maximum and minimums exactly? It's the same way we used to. Second, trace, and then they give you minimum and maximum. The only thing is you got to know where the minimum and the maximum is. I just clicked minimum, so I got to do this point down here. Left bound is to the left, right bound is to the right, and then it actually approximates my exact point. So I would say for my relative minimum, 3.3-ish. Depends what it asks you. I think this key is kind of weird. Some parts don't say, and some Some parts do say to the 10th place, so I'm going to do to the 10th place. And then our other y point is 4.3. And again, the key might be slightly different. It just depends what they ask you to round to, especially on Math Excel. Be careful with those. All right, so I'm only going to fill in that minimum. The key will tell you the relative maximum. But what you need to figure out is when this graph is increasing and decreasing. Now, I want you to figure out the actual points, but I'll tell you right here, there's 2 turning points on this graph loosely. This is my sketch, right? I'm going to change colors and use blue to define when I'm increasing. It looks like my graph is going up, right? As x gets bigger, y gets bigger, until this maximum point right here. But then this starts going down, right? So that is not increasing. It's only increasing on this other piece where it seems like as x gets bigger, y is getting bigger, right? You have to think of it using that definition. And then in this little green part right here, it seems that we are decreasing. So I will label those for you. And again, I want you to use your graphing calculator to figure out those numbers and fill in this piece. Okay. Again, this bottom piece is very similar. I want you to use your graphing calculator for these, sketch the graph, and then fill in that information. Use the key to check yourself and make sure you're focusing on this increasing, decreasing. We didn't get to go over it too much as a refresher, so we will when I get back to the classroom. But just keep that in mind that you kind of try to keep getting it right. It looks a lot easier on these polynomials because we don't have kind of, weird graphs going all wacky directions like we did when we were actually learning this. It's more graphs that just look like they're kind of going up and down, and you can really see, okay, at this point it's going up, right? Increasing, and at this point it's going down. Keep in mind those definitions, practice, and just check the key. Right? Try and do it without the key, check the key, whatever you have, try writing it in a different color and correct yourself. All right, so like I said, use the key, get working on that Math Excel and worksheet, and I will see you soon.